but I mean, it's a symmetric shape.
Yeah, sure.
Mm-hmm.
You'd say an answer if you had hit those endpoints, because it's not canceling out. It's like negative times negative, right?
No, it is canceling out. Because the value, this is an even function evaluated at two opposite points. These are going to be the same, so they'll subtract to 0. Yeah.
What if it wasn't symmetrical about the y-axis though? What would you do?
If it wasn't symmetrical, you would have to. I'll go through an example of it. It's because you would get a self-overlapping shape, and you would still have to cut part of it out.
So when you revolve around the x-axis, you actually count both.
Let me think about this. When I revolve around the x-axis,
You're not going to have to.
this shell or this disc was separate from this disc.
Yeah.
You see what I mean? So I wanted to count them both, but here I'd be overcounting if I counted them both.
Yeah.
Yeah. All right. So what does that change things to? That's 0 to 1. That's 0 to 1. So the second endpoint just disappears, right? Okay. So a fourth plus a half is 3/4. 3/4 of 2 pi is 3 pi over 2. Now that seems like a much more reasonable answer. Okay. There's a lot of shapes that you can do either way, right? So let me give you an example of something. Because the problem is, we won't always necessarily tell you which method to use. It's just find the volume revolving something around something, right? Sometimes you can do it both ways. Sometimes one is drastically easier than the other. So, and I think we're going to have a lab on that coming up at some point. So, by the way, don't let me get by without posting the pre-lab for next week today, because that is something you're going to need to work through. All right, so So let's take the region between y equals e to the x and y equals 5 lies in the first quadrant. So what does that look like? Well, e to the x goes up like that. Y equal to 5 comes across like that. So I'm taking this region and I'm revolving it around the x-axis, right? So what I'm going to get is a copy of that region down here, and it's going to be made out of circles going in between, right? So what does this thing look like? It looks like a cylinder on the outside, but then it's got, like it narrows down on the inside, right? So it's not a bowl. Looks like a finish washer. I don't know. So let's see. So that's what we're dealing with. So it's got a hole in it down on the bottom. So it's a bigger hole on one side, a smaller hole on the other side. That's kind of what we're looking at. Now, if I break this thing down the way I've been doing this, so that I use disc method, what kind of objects do I get? Because this is my little rectangle, right? Now, do you see where that's not connected to the axis anymore? What kind of thing do I get?
Your donut.
Yeah, it's like a slice of a donut. It's like a flat washer, right? So if you've seen washer method, that's what we're doing here, right? So do you see what I've got is a disc minus a smaller disc. Okay, so the volume of one disc, or volume of one washer, is what? It'll look like pi times an outside radius squared minus pi times an inside radius squared, right? Because it'll be a circle minus another circle. All right, and all of that times dx. Okay, so what is my outside radius and what is my inside radius? This is where you have to know what the pictures look like, right? So my outside radius looks like it's measuring that, right? So isn't that just 5? All right, how about my inside radius?
E to the x.
Yeah, because my inside radius is measuring that. So that's just the height of my function. So that's e to the x. Okay. So my volume should be the integral of, now I can definitely factor out pi out of this, right? Take out pi. So I've got 5 squared minus e to the x squared dx. And where am I integrating from? I'm in the first quadrant, so I'm 0 to somewhere.
To where they go.
Yeah, it's to whatever the intersection point is. If I set e to the x equal to 5, that means x is what, log of 5? Okay. So I'm integrating this from 0 to log of 5. Again, this is doable. This is pi times the integral from 0 to log of 5 of 25 minus e to the 2x dx. Right, because when you raise a power to a power, you just multiply the exponents. All right, so I can go ahead and integrate, I guess. This is 25x minus 1/2 e to the 2x, evaluated at 0 and log of 5. Alright, so I've got pi times 25 log of 5 minus 1/2 e to the 2 log of 5. I'm sure that can be simplified. And I'm subtracting off 25 times 0. And I'm adding on 1/2 e to the 0. Okay. This is pi times 25 log of 5 minus 1/2. Now I can write 2 log of 5 as log of 5 squared, right? So you see where that's just 25? Right, because e to the log of 25 is just 25. Alright, and then this is plus 1/2. Okay. So this is pi times 25 log of 5 minus,
12.5.
yeah, this is 12.5, and then I'm adding on another half, so just minus 12, is that right? Yeah, okay. Alright, that's about as far as I can simplify that. So that's what the volume of this thing is. What I'm interested in is there another way to set this up? Could we do the same thing by shell method? Let's take a closer look at what we're finding. Now you draw the region back up here. I had e to the x coming up like this, 5 coming across. What if I decided to split it up this way? do you see where if I'm going around the x-axis now I get shells? Right? So we can do the same region via cylindrical shells. Now, so the issue is my volume is now going to be the integral of 2 pi times the radius times the height, but we have to figure out what those things are. Okay. Alright, so this is my cylindrical shell. What's playing the role of the radius here? It's this distance, isn't it? So you see where it's just my y coordinate? Okay. And do you see where I'm going to have dy in my calculations? It's because the thickness of this thing is on the y-axis, right? So dy is going to be the small measurement. Alright, so what's playing the role of height? It's this, right? And so it's the x-coordinate. Okay, and then I've got dy, I've got a 2 pi out front. The problem is, what is x as a function of y? Now here, I know y is equal to e to the x. What does that mean x is? It's log of y. Do you see where if you're integrating with respect to y, everything has to be in terms of y. So this is 2 pi times the integral of y log of y dy. Now, what do you figure my limits of integration are? They've got to start wherever my rectangles start and end wherever they end, right? So it looks like they're going to end at 5. What's that bottom level?
1.
1? Right, yeah, because every exponential function crosses the y-axis at 1. Okay. Now, do you remember how to integrate this? That's integration by parts question, right? Okay, so I'm going to leave the answer up here. So I got 2 pi times, if I do u equals log of y, and then dv is y, that means du is going to be 1 over y, and v is 1/2 y squared. And so that means the integral of y log of y is what? 1/2 y squared log of y minus the integral of v du, which is 1/2 integral of y dy, which is 1/2 y squared log of y minus, it looks like 1/4 y squared, right, because the integral of y. So let's fill that in here. This is 1/2 y squared log of y minus 1/4 y squared. And so that's what I'm filling in at 1 and 5. So let's see if this comes out to be the same. I've got 2 pi times 25 over 2 log of 5 minus 1/4 of 25. And when I subtract, I got log of 1, which is 0, and 1/4. Okay. Is it coming out the same? The 2's are going to cancel out some. I've got a pi that I can factor out. These 2 cancel, and I get 25 log of 5. And this is 25 over 2, and then this is 1/2, is that right?
Yeah.
Doesn't that come out to be the same? Yeah, so it comes out to be exactly the same. Notice the difference in the procedure. When I did it by washer method, it came out to be a really easy integral, right? When I did it by shell method, I had to do integration by parts. So that's one of these things, is sometimes when you set these up one way, it's super easy, and sometimes when you set them up the other way, it's either impossible or ludicrously difficult. So that's one of the things we got to get used to, is if we have 2 ways to do it, make sure you know both of them, because one of them might be stupid difficult and the other one might be stupid easy. All right, that'll do for today. I do need my toys back, especially if you get that T-box.